Okay, so we proceed to Venturi meter. So Venturi meter, it is an instrument used to measure fluid flow in pipes. So we have this parang normal section niya, or that is the section of the pipe, then magkakaroon tayo dito ng converging section. So let's have this example. So a Venturi meter has an inlet diameter of 31 millimeters and a throat diameter of 19 mm. It has a mean pressure of 753 kilopascals and 550 kilopascals at the large section. So nilagay ko na lang siya yung normal section natin dito, that is section 1. Pressure is 753. Then yung throat o yung parang converging section nyo dito, that is 19 mm. The pressure is 550 kilopascals. So a large section and throat respectively. Assuming ideal flow condition, kapag ideal flow, okay, pag ginamit yung term na ideal flow, laging ina-assume dito that the head loss should be equal to 0. So kung mapapansin nyo, bakit dito sa normal size ng pipe or yung actual section ng pipe is mataas yung pressure, then biglang lumiit, okay, then bumaba yung pressure. So sa concept ng Bernoulli's, kapag mataas yung pressure, babagal yung flow. Tapos siyempre, kapag liliit yung section, mag-i-increase yung velocity. So ang mangyari naman is liliit yung pressure. So again, from Bernoulli's, there is an equivalent increase in velocity kapag nagkaroon ng pressure drop. Pero kapag tumaas yung pressure, babagal yung velocity. Okay? So we are just to apply here Bernoulli's equation. So this is a Bernoulli's equation or the energy equation. So let's assume this is just an horizontal Bernoulli. So let's say this is the elevation of point 1 is just equal to the elevation of point 2. So after the elevation head, then papasok yung other heads natin. So we have the pressure head at 1, P1 over gamma. Then the velocity at 1, B1 squared over 2G, horizontal line towards the second point. Then this is B sub 2 squared divided by 2G and P sub 2 over gamma. So yun yung ating energy equation. So ideal flow condition, head loss is equal to 0. Okay, if you are to construct the equation, this now, we have Z1 plus we have the P1 over gamma plus B1 squared over 2G is equal to, since head loss is equal to 0, this is equal to, we have the B sub 2 squared divided by 2G plus the pressure at 2 over gamma plus elevation at 2. Pero take note that kapag horizontal siya, Z1 is equal to Z2. So equal elevations. So we may cancel these two. Okay, then we have to simplify. This is P1 minus P2 divided by gamma. Transpose, that is, we have the B sub 2 squared minus B sub 1 squared divided by 2G. So given yung mga pressures natin, so maybe first thing to solve will be the velocities muna bago yung discharge before we compute the discharge. We have discharge is equal to area times velocity. Discharge area of the pipe is pi d squared is divided by 4 times velocity. So ang equivalent ng velocity in terms of the discharge is 4 times the discharge divided by pi, the diameter, squared. So ito lang muna yung gagamitin natin. You may use that. Or pwede naman in terms of velocity. Okay? So in terms of velocity, so continuity equation, ito, Q1 is the same as Q2. So for continuity equation, this is discharge number 1 is equal to discharge number 2. This is area 1, velocity 1 is equal to area 2, velocity number 2. So area 1, that is pi, the diameter is 31 mm, 0.031 squared, this is divided by 4. V1 is equal to Okay, dun sa throat section, this is 5.019 squared divided by 4, velocity number 2. So, pwede natin gawin is express V2 in terms of V1. Okay, so B sub 10 terms of B sub 1 is 2.66 to V1. Okay, then we may substitute dito. Okay, we have, using this equation, what is pressure at 1? Pressure at 1 is 753 minus the pressure at 2 is 550 divided by gamma water 9.81 is equal to, okay, dito we have B sub 2 squared, but equivalent of B sub 2, and the equivalent of B sub 2 is 2.662 of B sub 2.62 of B sub 1 squared, okay, minus B1 squared, this is divided by twice of acceleration due to gravity, 9.81 squared. So we may now compute for the velocity at section 1. So the velocity at section 1 is equal to 8.167. This is in terms of meters per second. So can we now compute for the discharge? Okay, so discharge. Okay, discharge is equal to area 1, V1. I'll be using V1 kasi yun naman yung na-compute natin or yes, gagamitin natin. So you have discharge is equal to area 1, 0.031 squared pi, this is divided by 4. Okay, multiplied by the computed velocity at section 1, or that is at the large section, is equal to 8.167. So we have the discharge na equal to so this will be equal to 6.164. This is times 10 raised to negative. Okay, negative 3 cubic meters per second. To be liters, multiplied by 1,000 liters is to 1 cubic meter. So para lang naman yung value, gawin natin siyang liters per second. So this is multiplied by 1,000. It will be equal to 6.164 liters per second. So that will be the discharge passing through this Venturi meter. So yun lang yung pinaka-purpose ng Venturi meter, just to follow the rule of Bernoulli to determine the discharge. Kaya lang, if we assume dito, if we are assuming that ideal flow or head loss is 0, but in actual, meron talagang head loss yan. You cannot actually eliminate head loss. So, dito, if the assumption head loss goes 0, we may assume this to be the theoretical theoretical discharge lang siya. So, if the head loss is assumed to be 0, if you are neglecting 0, then it is a theoretical discharge. So, paano naman natin kukunin yung actual discharge? So, in laboratory experiment, makukuha natin yung actual discharge okay, so mawala natin yung actual discharge. So parang ang gagawin lang dito is, yun, orasan ninyo Sa actual laboratory is yun, hahayaan lang mag-pass yung tubig. Okay? So magpapass yung tubig, tapos meron kang container dito. Yan. So meron kang container, tapos i-observe yung time. Mag-iipon ka ng volume dito. So mag-iipon tayo ng volume, i-consider mo or i-record niyo yung time. So basically, okay, we have the actual discharge, sabihin ko na lang Q sub A, Q sub T yung theoretical discharge. Ang discharge naman is volume over time. So actual discharge is yung naipon na volume dito, this is the volume divided by yung recorded time. So supposedly kapag sana may nasa physical laboratory tayo, yun yung gagawin. Okay? So what is the purpose of knowing the theoretical discharge and the actual discharge? Ano ba yung purpose ng dalawang yan? So that is to determine the coefficient of discharge. Okay, so the purpose of these two is to determine the coefficient of discharge of this pipeline or of this Venturi meter. So we have the coefficient of discharge, sabihin na lang natin na C sub D. This is the ratio of the actual discharge, flow rate actual divided by flow rate theoretical. Okay? So this is the coefficient of discharge. So siguro abangan nyo ito sa laboratory ninyo.